Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants a and b from z equal to ax plus by plus ab. So we are given a relation z equal to ax plus by plus ab, and we are asked to form a partial differential equation from this relation by eliminating a and b, which are arbitrary constants. Given a relation z equal to ax plus by plus ab, consider it as some equation 1. Now partially differentiate 1 with respect to x. Partially differentiating 1 with respect to x. Okay, so here we need to partially differentiate 1 with respect to x. So y will be treated as constant and z is a function of x and y. Okay, so we'll explain in detail and we'll see the shortcut also. So we need to find partial derivative of 1 with respect to x, right? So we'll apply dou by dou x on both sides of this equation. Which gives us dou z by dou x equal to partial derivative of first term plus partial derivative of second term plus partial derivative of last term. Okay, since we have a notation dou z by dou x equal to p, so let's replace the LHS part by p. We'll get p equal to, you can write this as constant a into dou by dou x of x plus partial derivative of constant with respect to x is 0. Since we are finding partial derivative with respect to x, so y will be treated as a constant. So partial derivative of constant with respect to x will be 0 plus partial derivative again of constant with respect to x is 0, which gives us p equal to a into partial derivative of x with respect to x is 1. Yeah, from this we'll get p equal to a. Therefore p equal to a. Consider as some equation number 2. Okay, now let's partially differentiate 1 with respect to y. Right, now apply dou by dou y on both sides of 1. This gives us dou z by dou y equal to dou by dou y of first term plus dou by dou y of second term plus dou by dou y of last term. Right, here we are doing partial derivative with respect to y. So we'll treat x as constant and z is a function of x and y. Okay, since we have a notation dou z by dou y equal to q, so let's replace the LHS part by q. We'll get q equal to partial derivative of constant with respect to y is 0 plus, here we can write this as constant b into partial derivative of y with respect to y plus partial derivative of constant with respect to y is 0. So you'll get q equal to b into partial derivative of y with respect to y is 1, which gives us q equal to b. Therefore q equal to b can be considered as some equation 3. Okay, now observe 1, 2 and 3. Okay, so we are having p equal to a or a equal to p. From 2 we'll get a equal to p. and from 3 you will get b equal to q, right? So you can replace a by p and b by q in 1 so that the arbitrary constants ab gets eliminated from 1, okay, and that results to a partial differential equation, right? We have 1 z equal to ax plus by plus ab. Substitute a equal to p and b equal to q by 2 and 3, okay. Then 1 becomes z equal to, replace a by p, you'll get px, plus replaces b by q, you'll get qy, plus replace a by p and b by q, you'll get pq, right? Therefore z equal to px plus qy plus pq is the required partial differential equation. Which completes the problem. Okay, let's now see the same problem by reducing the number of steps. So we got z equal to px plus qy plus pq, which does not involve any arbitrary constant, and also we can say it is of the form some function of x, y, z, p, q equal to 0 form, right? Fine. Now let's see the shortest way. Now we are doing the same problem, okay. Given relation z equal to ax plus by plus ab, we have considered as equation 1. Now we'll partially differentiate it with respect to x and y. Firstly, we'll begin with x. Dou z by dou x equal to, we know that we are doing partial differentiation, I mean partially differentiating 1 with respect to x, so y will be treated as constant, right? So here you are having x, right? So you'll get a into partial derivative of x with respect to x is 1 plus partial derivative of constant with respect to x is 0 plus partial derivative of constant with respect to x is 0. Since we know the notation that dou z by dou x equal to p, right? Since dou z by dou x equal to p, so let's replace dou z by dou x by p. You'll get p equal to a. A into 1 is a. We have considered as equation 2. Now partially differentiating 1 with respect to y. Right, you'll get dou z by dou y. We are doing partial differentiation with respect to y, so we'll treat x as constant, and we know that z is a function of some x and y, right? Now we'll get dou z by dou y equal to, here x is treated as constant, so we have a constant ax, so the partial derivative for constant with respect to y is 0 plus b into partial derivative of constant, partial derivative of y with respect to y is 1 plus partial derivative of constant ab with respect to y is 0, which gives us, since we have notation dou z by dou y equal to q, so let's replace dou z by dou y by q. We'll get q equal to b into 1 b. This is considered as equation 3. So from 2 and 3 we'll get a equal to p and b equal to q, right? So substitute, just observe 1, 2 and 3, okay. If we can say that by replacing 2 and 3 in 1, or by substituting, we can say by substituting 2 and 3 in 1, a and b, the arbitrary constants, gets eliminated from 1, so we can substitute, or yeah, substitute 2 and 3 in 1. we get z equal to a is replaced by p into x plus b is replaced by q into y equal to a into b, which gives us z equal to px plus qy plus pq, which is the required partial differential equation. Right? Which completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.